I have 11 examples of graphing using our tools of calculus. Unless otherwise stated, I want a clear sketch of the graph equation. And in the graph, identify all intercepts, all local extrema, and all inflection points. So in doing that, I will first build a sine graph for the y values. That is to say, ascertain over what intervals the y values are positive or negative. That is to say, ascertain over what intervals the curve lives above or below the x-axis. So just as you were trained to do when you studied pre-calculus, I'll plot the zeros of both my numerator and denominator because this is merely a rational function. And I'll test those intervals, I think. No, I won't. I take it back. Testing just one interval. If I plug something in for x over here to the right of 2, like a billion, clearly everything's positive. Now, this is 0 of a linear factor raised to an odd power, so it acts as a toggle switch. I'll get a sign change. This is 0 of a linear factor raised to an even power, upstairs or downstairs, which means it will not act as a toggle switch. I will not change signs on either side. Next on my list, so there's y. Let's go ahead and identify what y prime looks like. I'm the one here with the limited board space, so let me pull out my piece of scratch paper and compute the derivative. And build a sine graph for the first derivative function. I'll plot the zeros of my numerator and denominator and test. I'm positive right of 5 because when I plug a billion for x here and here, the whole thing's negative. But both these zeros upstairs and downstairs act as toggle switch because they're zeros of linear factors raised to an odd power. Next on my list, I want to build a sine graph of the second derivative function, but that means I need to find out what the second derivative function looks like first. And so let me see. So looking at that version of the first derivative. And now building that sine graph, I'll plot my zeros upstairs and downstairs. When I test this interval right here, clearly everything's positive, but that's a 0 of a linear factor raised to an odd power. It acts as a toggle switch. That is not the 0 of a linear factor raised to an odd power. It will not act as a toggle switch. Now, as I suggested, this sine graph tells me over what intervals I'm positive or negative with my y values. But the first derivative sine graph tells me whether I'm decreasing or increasing. The second derivative sine graph tells me about my concavity, down, down, and up. And I'll put it all together to sketch the graph. Let's see how clearly I can make this. Well, with no calculus tools, you clearly understand that 2 is the x-coordinate of the only x-intercept. The y-intercept at a quick glance is 0, -2. I am positive to the right of 2, negative to the left of 2, and there's a vertical asymptote at x equals -1. Again, just because of what I know about rational functions when I studied these in pre-calculus. Now, it looks like to the left of the vertical asymptote, I live below the x-axis, but there's a vertical asymptote at x equals -1. There's also a horizontal asymptote at y equals 0. You know that because it's a rational function for which the degree of the polynomial upstairs is strictly less than the degree of the polynomial downstairs. So for free, I get a horizontal asymptote at y equals 0. Now I'm below the x-axis, I'm continually decreasing, and I'm concave down, and I have to hug this x-axis and this vertical asymptote. I must behave as such. Now, just to the right of that vertical asymptote, my y values, at least for a little while, are still negative, but I'm increasing and concave down. I pass through the y-intercept, I pass through the x-intercept. That's not very good, is it? My goodness. However, after I pass through the x-intercept, my y is become positive, but I locally max out at x equals 5. And then I, from there on out, decrease, but I got to hug the x-axis, and I change from concave down to concave up at a value of x bigger than 5, specifically at 8. Concave down, change to concave up, hug the asymptote. Where that point right there has an x-coordinate 8. Now, to get the corresponding y-coordinate when x is 5, I'll plug 5 in for x. Instead of 3 over 36, or 1 over 12. To get the corresponding y value when x is 8, I'll plug 0 for x in the original relationship between x and y. I said 8, didn't I? Is that a 6 over? Is that an 81?